Good morning, everyone. Thank you for coming. My name is Jens. I'm a software engineer from Belgium. I'm also one of the co-organizer of the Flutter Belgium meetups. I actually started working with Flutter in 2018 after one of those Flutter Belgium meetups. And today we'll be talking about building and maintaining large-scale design systems in Flutter. Because for the last few years, I've been doing a lot of work for a Belgian scale-up company called InvestSuite. And they make white-labeled business-to-business wealth tech solutions. And in the process of doing that, we've actually learned quite a lot about working with design systems in Flutter. Specifically, what makes them work, what doesn't make them work, and what are some good tips and tricks if you're trying to build your own. So what we will be covering, first of all, quick introduction, then what did we set out to create, then some ground rules that we think make up a good design system, and then specifically a good multi-brand design system. A few notes on naming, because naming is important, and then we'll dive into the design system and its style guides. I'll explain how we deal with exceptions, and then how we pushed it further by tokenizing as many things as we could possibly tokenize. And then finally, how we make it scale by making Flutter and Figma the very best of friends. And I'll close on some next steps. So first of all, a quick introduction, because all of what I will be presenting here today has been a massive team effort. It's been contributions from all of these people that has made our design system what it is today. I'm just a lucky person that gets to talk about it at FlutterCon. So what was our goal? Within InvestSuite, as the name says, we built a suite of investment products. And this presentation mainly covers the principles that we apply to our self-investor product, which is for the self-directed investor, our robo-advisor, which is automated investing, and our storyteller product, which is for portfolio reporting. Why those three? Because we have more products, because those products have front ends that need to be configurable. And for our robo and self products, those are the ones that are actually built in Flutter. Storyteller is in React, but it uses a lot of the same principles that I'll be explaining here today. So what was our goal? Our goal was to take these white label products, and we had the ambition to serve multiple clients with one code base, while at the same time making sure that the applications feel like theirs, like they are from the bank. And we wanted to have the possibility to customize them far enough that they all feel unique. Because as a bank, you don't want to look like your competitor. You don't want to look like you are offering the same product as your competitor. It needs to be different. But it also needs to look like it's yours, because otherwise your clients are not going to trust your product. They need to recognize your brand in your product. So that's quite easy, right? No, not quite. So what was our plan? We tried to figure out how we would approach this, and we decided to start with the basics. So first of all, try to figure out what a good design system should be in its essence. And then we were going to add on all of the other features that we think are important to support. So support multiple brands within our design system. Make it highly configurable, but also make it easy to configure, because it should scale really well without losing its maintainability across multiple clients. Then we are targeting a global market, so that means that you need to support multiple languages. And if you're talking about supporting multiple languages, that also means that you need to support different reading directions. So right to left versus left to right. That relates back to how we deal with assets, for example. And then also keeping in mind that if you're using different character sets, that your font sizing and your font spacing needs to be different to keep your text readable. So let's start with the basics. What do we think makes up a good design system in its essence? And the honest answer is that when we started out, we had no idea. Because what's important to note is that there are a lot of methodologies out there about good design systems, but not a lot of them translate very well between design and development. And we feel that a good design system only works if these two key stakeholders are fully aligned. And that should actually be the main goal of your design system. Even if that means breaking certain conventions in your normal way of working, it's probably going to be worth it to keep your design system alive and aligned. So rule number one, a good design system should be stable. Both design and development should work within the same constraints. if something is done a certain way in design, you should replicate that in development. And vice versa. If something is done in development a certain way, you should do it the same way in design. And while that might not be the most comfortable way of doing this, it's the most secure way to prevent unexpected behavior. And a good example about that is how we deal with assets. Because different brands have different visual languages that they use. Some might use a lot of illustrations, others might use a lot of photography, for example. So when we are talking about placing visuals in the UI, we're not thinking about a specific visual. We're thinking about an area where an asset could be placed. And what we're really defining is the boundaries of that area. And then whatever the brand decides to place in that area should not matter, as long as those constraints within your UI are respected. Rule number 2 is a good design system should be flexible. And that's especially if you want to go multi-brand, because flexibility then is everything. And this is really a shout out to the design side of things, because if you're going to try and undertake an ambitious task like making a multi-brand design system and make it configurable, the last thing that you want is to feel limited by the design system itself. And you don't want to bump into the limitations of that design system when you're trying to create an exciting new UI. So you really want to push how flexible you can be for your designer to build exciting new UIs and to make it really nice to use for your user. On the other side of that is that your good design system should be scalable, because your flexibility is really nothing if configuring it is really hard. So it needs to be fast and easy. If you have to do too much manual work, then your design system loses its value. And walking that line between scalability and flexibility is a really, really hard balancing act that you need to get right. And then finally, in a good design system, design and development are fully aligned. There should be no interpretations, no slight variations. The devil is really in the details, and it will come back to ruin your day at some point. Sidestep, use the right tools. And for us, the right tool is Figma. We think Figma is excellent to support our design system designs. If you hear me referencing design files in this talk, you can assume that they're Figma files. Another note on naming things, because if you want to be fully aligned between design and development, we have to talk about naming things. You need to speak the same language. And initially we made the mistake of not doing this, and it just leads to confusion. So use the same names for your components, for example. Unfortunately, naming is really hard, and we all know this, but it's also one of the most important things within a design system. And a lot of work that you actually do within a design system is just communicating back and forth between design and development. So if you can remove the noise and the confusion from that communication, you gain a lot of effectiveness, and you should actually opt for clarity to avoid that confusion. Now, within InvestSuite, we use 2 naming conventions, which, regarding what I just said, might be confusing, but we felt really the need to split between a naming convention for components and one for screens, which in the context of Flutter is even weirder because everything is a widget. But to be able to properly communicate with our designers, we needed to split them. And I will highlight them a little bit later in this talk, what these conventions are exactly. So now that we've defined our rules and we've defined our playing field a little bit, let's start with what is arguably the easiest part of building a multi-brand design system, which is the branding part. And for us, brandability is all about our style guide and the tokens that are being used within that style guide. So our token structure, they're all following that same pattern. And it's this, what you see here. First of all, you have a color group, and each color group has 3 emphasis layers: high emphasis, medium emphasis, and low emphasis. And each emphasis layer has 5 shade layers. And each shade layer has a container and on-container combination. And I'll explain those a little bit more in a second. But first, the color groups, very simple. We have primary, secondary, surface, and then we have our semantic colors, which are info, help, negative, warning, and positive. That container on container thing, it's something that we borrowed from Material Tree, and it's really there to determine what foreground colors can be used on which background colors. And by linking these two tightly together, you keep an overview of what colors are used in combination with each other. Because don't forget that we are multi-brand, so your colors are going to change during some point, and you don't want to lose an overview of what colors are being used together and have, for example, contrast issues if you are branding your app. So by keeping these two tightly linked together, you can avoid these because you will always know which two foreground, background colors are being used together. We used to solve this completely different, a lot more complex, and then Material 3 came out with the container on container methodology, and we kind of hit ourselves in the head that we didn't think of that first, but use it, it's really good. So following that same logic, we also want to avoid having to combine too many tokens together. So we render all of our text styles under all of our color tokens. So if, for example, you want to have a red text somewhere, we go through or a primary color text, for example, we go through the primary token and then we select the text style that we want to avoid having to combine two tokens together. Not only is it nice that you can just reason over it, you go through the color to what text style you want, but you also don't have unexpected combinations of tokens, so you can avoid those as well. Assets, also a super important part of the style guide, which means that we also tokenize these. And these are just, there's no real structure to these. We just use them as a flat map. And the reason for that is that we want to discourage the reuse of an asset in the app. Because you might forget the places where a certain asset has been used and assign a new asset if you're branding for the context of like one page where it's used. But then it also changes in 4 other places that you forgot about. And then maybe the illustration looks super weird on those 3 other pages. So we really kind of want to use unique assets, but we still want to tokenize them so that we can easily replace them. There is one cool thing that we do with assets though. That is, if you convert your assets in Figma into components, you can assign properties to them. And with these properties, you can create asset variants. And asset variants are really, really interesting because you can use them for a whole range of functionalities. Like, for example, you can create language variants of your assets, which is really cool. If you have like an illustration and there's text in the illustration, you could swap that asset with translated text. Or if you're in a right to left UI and your asset loses its meaning, if you put it left to right, you can flip the asset from to right to left. We do deal with a lot of finance, so there's a lot of graphs in our illustrations, for example. And if you're reading right to left, you need to flip the graph as well. So that way we can deal with this. You could deal with active, inactive states. You can assign currency icons, which is for us also a big one with asset variants. Or you could deal with platform-specific icons because we are still working in Flutter. We're serving multiple platforms. This is a way that you could automatically assign platform-specific icons via the variants. And to facilitate this, we use something we call a design system asset. And a design system asset will internally select the correct asset from the variants list based on the properties that you pass to it. In code, that looks something like this. So you would call that .widget method on the asset and then just pass it a properties map. And in this case, we're just passing it a currency. So this is most likely a currency icon that will then be selected correctly based on what currency code you actually pass to the currency icon. Now, what you don't want to risk is not showing an asset. So what we do is we score our assets. And what the design system asset does is it returns the asset that is most likely to match with the given properties, which it just removes the risk of not showing an asset, but it's also very useful if you're just setting up a new style guide and it's not quite optimized yet and not all the illustrations are quite there yet, then the app doesn't look broken because of missing assets. You still show all of the default ones. So a multi-brand design system poses a specific challenge because their color pattern changes. And what that means is that the brand colors can significantly affect your UI. If, for example, you are a bank and your primary brand color is red, then all of a sudden your buttons, they might start looking like destructive actions, or your text might start looking like error messages. So we had actually this real world example where the primary brand color from a bank was bright yellow. And by default, we use the primary color for all of our buttons. And all of a sudden, all of our buttons were yellow and the contrast was ruined and it was ugly and ugh. So what we did was we did a full analysis of all of the components that we have, and we identified a whole new category which we call brand impact components. And these brand impact components, they get their unique token set applied to them. And by default, these tokens will just follow the normal style guide that you apply. So by default, we just apply the primary color to the buttons tokens, for example. But if you run into a case where, like for example, your color is yellow, you can override this brand impact token, which is unique for that component, while leaving the rest of your design system unaffected. And you might as well call these brand impact tokens just exceptions, but we don't really like the name exceptions in a well-organized system, so we went with brand impact tokens. Now, how do we provide these tokens to our widget tree? It's just simply via inherited widgets. And within InvestSuite, we're big fans of the provider package, so we just use provider to provide our own theme. We don't use Flutter's default theme data, mainly because we don't want to deal with overriding a lot of stuff or accidentally breaking a lot of stuff. We want to have full control over what that theme is and does. So we provide it ourselves via a separate provider to our widget tree. So quick summary on the tokens, just make them easy to use. That's the gist of it. You want to avoid having to combine too many tokens together. Use that container-on-container methodology. It will save you a lot of headaches if you're rebranding. Render your textiles under your colors. It's actually really useful. We find it really, really easy to work with. And most importantly, use a structure that works for your project, that really makes sense for you. Now, if we have this, by applying all this into our project, we are able to brand and theme our app. And that's already great. But after setting up that whole initial token structure, your UI still looks exactly the same for each app. So maybe a client wants to visualize something completely different. Maybe they have a very specific way of visualizing graphs, for example, and we can't facilitate that yet. So it became apparent to us that we actually needed to push this a lot further. And we started thinking is that if you can tokenize colors, you can tokenize textiles, then you can tokenize widgets as well. You could tokenize screens. You could even tokenize entire functionalities within your app. However, there's one really important thing to keep in mind if you start to do this kind of thing, and it's this. You can visualize data differently, but you cannot visualize different data. And you need to keep that in mind, and you need to make that a rule if you're tokenizing widgets. Because if you're trying to visualize different data by tokenizing a widget, you're doing something wrong somewhere, because you're going to end up writing custom code that you probably don't want. So to do this, we introduce something we call an app widget. And the main point of an app widget is to wrap your normal widget into a component with a builder so that it can be placed on a provider. And from that provider, it's placed on a token. And from that token, you can call that in your UI and actually get the component back. And this is a simplified example of what that looks like, but the main essence is there. You have your app widget, it has a builder method, and you have that .widget method that you pass the current context and a set of parameters. And that will call the app widget builder. So how you use that then in a widget, and this is an example. For example, a vertical bar widget would be maybe something that you use in a graph or something. It's something abstract. But you would have a static app widget method there. And that would return the app widget. And that app widget has a builder that actually returns the vertical bar widget in itself. If you then use that on a provider, you'll see that there's a token there, and it's called graph widget. And the graph widget just takes graph widget params, which is generic. In your constructor, you have the possibility to override what graph widget means, meaning configurability. If you don't override it, we will return the vertical bar widget by default. And we consider it the best practice to always provide sensible defaults for our tokenized properties. And the reasoning behind this is that you want to have maximum configurability, but you want to keep the amount of config work that you actually have to do as low as possible. You only want to override what you really want to change. And in practice, we've learned that that's actually not so much. So this is how you would use that in a view. You would call that provider, call the specific token, pass it the parameters, and you then get, if you didn't override it, you get the vertical bar widget back. If you overrode it, maybe with like a horizontal bar widget, for example, that would be the new widget being returned. The only constraint here is that both these widgets, they need to know how to visualize, for this example, population data, for example. So this is where that first naming convention comes in. And this is the convention that we use for our components. And what you need to know to understand this naming convention is that our code is structured on a monorepo. We have a core package where we put all of the shared components, shared functionality, shared logic is all in that core package. And then we have different packages per what we call plugins. So for example, the Robo product would be a plugin. It has its own package. The Self product has its own package. And then we have a whole list of integration packages with other systems that we do, payments, flows, all that kind of stuff. They're all in packages. And the first part of that name always references where that component is hosted. So in which package it's hosted. In this case, it's in core. That second part is a functional group. And that functional group, it doesn't really follow things like atomic design, for example, because we found that atomic design is a little bit too generic and doesn't really cover what we really needed from a functional group. So we made our own that really makes sense for the products that we are building. So for example, we have a functional group called graphs. And then that final part is a descriptive part of what are you going to visualize here. And it doesn't need to be descriptive of how it's actually visualized. For example, this is really, it's going to be a bar and you know that it's going to be a bar, but it might be as well core graph population data or something like that. And that's a graph that knows how to visualize population data, and that's all that you need to know about it. So I mentioned that we have this mental split between widgets and screens. So we also tokenize all of our screens. So we allow clients to, if they have a screen in the app that they don't particularly like or where they would like to add or remove stuff, we can override a screen somewhere in the app without actually really touching the core functionality of our code. The difference between these two is that screens have route information attached to them instead of just calling a .widget. So this is something that we call an app screen, and the main principle is just the same, but as you can see, there's this .route method, which will return a material page route instead of just a widget, if you call it. They're also hosted on a provider and tokenized, but in the UI, you would call it something like this. So you'd push them on the navigator stack. You call your provider, your token, and then your .route method. And then you get the screen wrapped in a material page route and all of the transitions go through. You can also pass parameters to it, also possible. So another example of a naming convention that we used, and this is the one that we use for screens, which is different. But the reasoning behind this is that a lot of our app is actually a sequence of screens, a flow of screens. Like for example, if you are buying an instrument, an order flow is really just a sequence of screens that you have. And that first letter is still just for the package. Here it's just the letter that we use. But then we use 3 numbers. And it really resembles what Semver looks like. But we actually numbered all of the different features that we have. So you would, for example, have feature 6 or feature 5, something like that. And we know what that means within the team. And the second number identifies where you're positioned inside of that flow. So if you are the first screen, you have number 0. If you're the second screen, you have number 1. And that third level is if you open an overlay over a screen. So for example, R611, for example, would be feature number 6, the second screen, an overlay over that one. And then we also have a descriptive part to just describe a little bit what we're doing in that screen. But while that might seem like a very complex and weird way to communicate about screens, it works super well. Like internally, we're talking about, I'm working on screen R620 today. And everybody knows what that means and what you're exactly working on. Where previously we were actually describing the screens that we're working on, like I'm working on the portfolio proposal screen, for example, but we have like 4 of those. So which one are you actually working on? And with that number convention, that confusion is gone. So it works really well. So to reiterate a little bit, create granular configuration, but use sensible defaults so that you don't have to rework, do a lot of configuration work if you're setting up a new app that you're going to brand. And then finally, you probably also want to create libraries of your widgets and screens. And currently we have a configurator tool which actually wraps our normal tool. It reads out the providers, automatically indexes them, and makes examples of all of the widgets and components that we have and all of the screens that we have. I don't recommend you do that. This was done before the release of great tools like Widgetbook and Monarch and all those tools. Just use them. They're better. Go for them to actually build libraries of your components, because you probably do want to do that. So now we actually have a highly flexible app. We can brand it by using our style tokens and from our style guide. We can change assets from our style guide. And we can actually provide different components, different screens, if our clients want to swap these out. And that's really good. But that's also a lot of config. So how do we now scale this? Because there are some remarks that you can make on the previous setup. The most important one probably, all of these style guide tokens still needed to be configured manually. And if you're going multi-brand, that means each time that you're setting up a new app, you're copy-pasting values from Figma into your code editor. All of your assets and all of these asset variants needed to be downloaded manually from Figma, which is just tedious work and you don't want to do it. And then an important one, the readability of our code actually declined quite a bit by using these tokenized values for components and screens. And then very specifically, if you have a lot of parameters that you're passing to them, it becomes really hard to read. So let's try to fix that one first, maybe. So ultimately, you kind of want to use the one on the right, not the one on the left, because that's readable. That's how you normally would create widgets on Flutter. So how do we now achieve this one? And to do this, we built something called a component adapter. And the idea behind component adapter is that we move the provider back inside of the widget, which leads to better readability of our code. This is what the component adapter roughly looks like, but that's not very important. What's actually important is what it looks like in a widget, because each first line of a tokenized widget is now changed. And instead of just running your build method, we first call the component adapter.adapt. And component adapter is also just a provider that we provide on the context. And in that component adapter, we actually check, is there for this widget an alternative available? And if so, we return that alternative. If not, we return the default widget, which is the callback methods, how you would normally render it. How we provide component alternatives is also slightly different now, because we're not building a full index of all of our tokens that we're building. We're just checking if a widget needs to be overwritten and returning that. Because now we know from experience that what you actually need to override is not that much. So this kind of approach makes more sense, because then you have more readability. But actually the most important thing is, this is now what our tokenized widgets look like in our code. So they look like regular widgets and are very easy to use. Second one, reducing the manual work when you're updating the style guide. And this is a big one, so I split it into multiple points. Because the first one is that Figma allows you to build plugins. Yes, it's running. And Figma plugins, they can actually access almost anything that is on your Figma artboard. So you can get your local text styles, you can get your local paint styles, you can get your effect styles. And if you can parse these objects, because they're just plain JavaScript objects that you get back in a list, that means that you can parse them as JSON. And that means that you can take that JSON, you can load that into your application, and then parse that into what would be your theme, into your tokenized style guide. And that's what we did initially. So I built a plugin for Figma that reads out these components, and then just copy paste the JSON into our project. It generates a style guide. It works really nice. But as our style guide became larger, we noticed a startup lock when we were starting our apps. And we did an analysis, and we noticed that it's actually the parsing of that JSON that could lock up our app to almost 2 seconds on startup. Okay, problem. We started thinking, and we reasoned that if you're able to generate JSON by exporting from a plugin, then you might as well just generate Dart code straight away and pre-compile it. So that's what we did. We adapted the plugin to, instead of generating JSON code, it now generates Dart code. You can copy paste that into your project done, start the plug, gone, really good. But you're still manually copy pasting information from Figma. And while that's really excellent, you don't really want to be manually copy pasting Dart code into your project each time that you want to set up a new style guide. So luckily Figma has a really, really excellent API. And the API takes some getting used to because it's not complex, but it's actually really well constructed, but you need to figure it out a little bit. But it uses those same principles that the plugins use, which means that you can access everything that's on your artboard, which is really good. So we started doing that, and we already had the knowledge of how to interpret what we get back from the artboard and configure that into Dart code. So all we had to do was move out of a plugin and move it into a Dart package that we could run on our CI. And now we're no longer copy pasting code from Figma plugin into our code. We're just running one command and automatically syncing the full style guide into our code, which is really nice. Now, like I mentioned before, we're still manually updating these assets, but you can also access everything that's on your artboard, which means that you can manually download automatically download your assets from Figma as well, which is what we did. Now, there's one thing to keep in mind with downloading Figma assets, and that is that if you're downloading Figma assets via the API, Figma requires you to specify a format that you want to download them in. And the most logic format to download them in would be SVG, because Figma is a vector-based program. But if you are not dealing with an SVG, Figma will do that thing where it wraps a bitmap into an SVG and pretends like it's an SVG. So we had to build a check for that to detect those and then re-download those as bitmaps. But also, if you have really large SVGs, they tend to slow your page transitions because they're just too heavy. So we also have a size limit on what we download as SVG. And if we go over that size limit, we also download it as a bitmap. Now, when you're doing all of this, that automatic syncing and downloading, that's all really cool and it speeds up your process a little bit, a lot. But you're probably going to want to add contract validation. Because we noticed very quickly when we started automatically syncing things is that automatically syncing things is really great until you break something. And you will, especially with a really large multi-brand design system, you are going to break stuff. For example, if you are just setting up a new style guide or you change a value somewhere and then all of a sudden your sync is broken. So we introduced contract validation. And we really approach that in its most simple form. Yeah, it's right. So each time that we reach a stable version of our style guide, we, in our asset library, we create a JSON format that outlines the structure of that style guide and the asset library. And if you're downloading a new style guide, we compare what you're downloading to that contract that you defined as your stable version. And if there's a mismatch there, we throw clear errors over, hey, this token is misnamed, I'm missing this token there, that kind of stuff. And we get very clear errors if something goes wrong. Like that. And we have that in two places. So we have that as a Flutter Figma plugin for the designers if they're setting something up new, that they can actually check whether everything works and they didn't actually break something. And we also have it on our CI so that we don't accidentally generate broken themes and then only notice it when we are at runtime building the app and then something breaks because there's a style token missing. So that contract validation actually saves us a lot of time. So what do I see as next steps? First of all, I think most of you will probably know that Figma did a big release a few weeks ago in June where they introduced variables. And variables are really, really interesting when it comes to design systems in general, but also specifically multi-brand design systems. For example, now we had to do hacks to be able to sync border radiuses, to sync spacing properly. Variables will just solve that. We are still having an issue with our API access. There's something with the enterprise license that's not quite working with the API access. So we're still waiting for Figma to resolve that currently. But as soon as that's resolved, we're just going to throw away these hacks and start using variables and automatically sync these over the API as well. Secondly, I think it would be really cool to open source some of this stuff because there are some Figma libraries out there that allow you to download Figma, but they delete a lot of the useful stuff that Figma gives you a lot of the information that Figma gives you on your components, on your tokens, all of that stuff. So it would be interesting to open source this, and also like the contract validation. I think that would be interesting to deliver that as a package. And then this is like a personal wish list for me. It would be really cool to have automatically update everything, because now we still need to run the task. Automatically doing all of that, that would be like my, then we don't have to do anything anymore to multi-brand our apps. And that's it. Thanks.